So I've got a ball here, and I'm going to hold onto it, and then I'm just going to drop it. And I'm going to drop it off of, let's say, a roof that's 10 meters off the ground. What's that going to look like? What's going to happen? Well, I mean, if you've ever dropped a ball, you know it's going to fall to the ground. But when it falls, what's actually happening to it? If we have a variable list here, and I'm not going to use x, I'm actually going to use y because we're dealing with a vertical motion. I've got y naught, v naught, v, a, and t. Does the displacement suddenly change? Does it just magically go from 0 to 10, or from 10 down to 0? Does the velocity change? Does it fall at an exact constant velocity? Do different things fall at different speeds? Does it accelerate? There it is, it accelerates. Now, this is going to be a huge point in physics. We're going to prove this in a couple of units when we start to study the force of universal gravitation. But everything on the Earth will fall at the same rate of acceleration. This was one of Galileo's big ideas. He posited that if you dropped a bowling ball and a bundle of feathers from the same height, if there was no air resistance, then they would land on the ground at the same time. They would fall at the same rate. And that is a very specific rate. So let's write out this variable list and let's solve this kind of problem. My y naught, I'm starting at a height of 10 meters, so that's my initial height. My final position will be hitting the ground, so that'll be 0. And I'm just letting this go. So when I drop it, right before I let it go, what's its velocity? 0, right? Okay. And then we're going to have an acceleration. And when we look at things falling because of gravity, not only do we use y instead, but we also use this constant g. G represents the acceleration due to gravity, and it's equal to negative 9.8 meters per second squared. Now this negative here is because our frame of reference says that this is 10, ground is 0. We could flip this frame of reference, then this would become positive. The thing that is always going to stay the same is that when we are near the Earth, the acceleration due to gravity on the Earth is 9.8 meters per second squared. So we plug this number in for our acceleration. So I can set up this equation. Y equals y naught plus v naught t plus 1/2 gt squared. Y naught is 10. I'm going to subtract that from both sides immediately, giving me negative 10 equals, and then v naught t is 0. And so I get 1/2 times negative 9.8 t squared. And I can figure out what is the time that it's going to take to fall. 1/2 of negative 9.8 is 4.9. And so I can take negative 10 divided by negative 4.9 equals t squared. And then I can take the square root of that and get myself the exact value for t. And when I do that, I get time equaling 1.43 seconds. Let's say I'm standing on top of a 75-meter cliff, and I throw a ball straight into the air with a velocity of 15 meters per second, such that it is able to fall to the bottom of the cliff. So the ball is going to land at the bottom of the cliff where it's 0 meters tall. How do I solve something like this? Well, let's put together our variable list, and let's solve this. My initial height is going to be 75 meters. I'm at the top of that 75-meter cliff face. Should be able to pull that out of this problem. And I'm going to land at the bottom of the canyon, so it's going to be 0 meters. My initial velocity, that's given, that's 15 meters per second. I don't know my final velocity, but I do know that this is going to be falling. While it's rising, while an object is rising, it is going to be experiencing a downward acceleration equal to negative 9.8 meters per second squared. It does not matter which direction this object is moving, it will be experiencing a constant pull, a constant acceleration as long as it is in the air. Until it hits the ground, it is going to be falling with an acceleration of negative 9.8. Okay? That is going to be a question on the AP exam. At some point you will be asked to compare either two objects falling, maybe one object is thrown down, one object is thrown up, and you'll be asked about the rate that they fall at. they will be falling at that exact rate. It doesn't matter if this has a positive velocity of 10 meters per second, while something else has a negative velocity of 10 meters per second. They will both get this same acceleration. It makes no difference which direction they're moving. And so whenever I have something moving through the air, it's going to have that negative 9.8 meters per second squared for an acceleration. So now that we have all of that information, let's set up a formula. Now when I set this up, you might notice something. I have two spots where I have my unknown variable, t and t squared. What kind of equation is this? Well, this is a quadratic equation. And that should make sense because my motion is going to be a parabola. If I track my motion over time, I'm actually going to be moving like that. If I were to graph this out, if I were to graph my height over time, I would get a clean parabola. I'm going to be slowing down with a positive velocity, and then I'm going to turn around and I'm going to start falling with an increasing velocity until I hit the ground. And so I can use quad form to solve this. If I'm using a TI-89, it's very simple. I just use the solve function. I can punch all of this in directly, replacing the t's with x's, and I can hit enter, and I can get my answers. But if I'm using the TI-84 or a calculator that I have to program, then I'm going to use that quad form function. I'm going to have an A, I'm going to have a B, I'm going to have a C. And so I need to identify which is A, which is B, and which is C. A is traditionally going to be the thing that is next to the variable squared. So if this were quad form, this would be 0 equals ax squared plus bx plus c. So we just have this flipped because of the way we write our displacement equation. So my c value is going to be 75. And it's going to be a positive 75 because I started at a positive 75. My b value is going to be 15. It's going to be a positive 15 because my initial velocity is a positive 15. That's how I've defined my frame of reference. My frame of reference is pretty much always up is positive, down is negative, and I usually do to the right is positive. But that's kind of irrelevant. My a value here, this is going to be my acceleration due to gravity. But remember, we have this 1/2 g. That 1/2 has to be included in that a. So the value of a is actually 1/2 of negative 9.8, which is equal to negative 4.9. So we need to be very careful when we enter that in. But if we enter this into quad form, then I will get two values for t. And I need to figure out which one it is. There is only one answer. I've got negative 2.67 seconds, or I've got 5.73 seconds. Now, which one would that be? Well, keep in mind, when we do this quad form, the numbers don't know that we started at this specific height. They're going to track that equation as if this was a parabola going all the way down on both sides. Well, all of this is going to be before our situation started. So any negative value for time is going to be before we started our problem. So that is not correct. We can never have a negative value for time. So t is never negative. So we can cross that out. We're not going to have a negative time. So we're left with a positive 5.73. Sometimes you'll do a quad form and maybe you have something that has an initial velocity or you're ending at the same height that you started at, and you're going to have one of your values of t being 0. Well, that would just mean that the time it was at that height was at t equals 0. That makes sense, but that's not going to be our final answer. So we do need to think about what these time values mean. If you were to get two positive values for time, you need to think about which one could be correct. Because I could have something gaining up on something else, and it's going to hit it at a certain time. So we need to be able to think of what does this situation look like. That's why we draw out these models so we can have a better comprehension of what's going on. So you should be able to solve problems related to gravity now, because gravity is just going to be falling at negative 9.8 meters per second squared.